This is Algebra 1, Lesson 8C, Areas of Triangles. So we've discussed rectangles and squares in a previous video. Now we're going to talk about triangles. But first, let's start with something we already know, and that's a rectangle. What's the area of this rectangle? Well, we know that area equals length times width, and we know that that is 4 times 3, which is equal to 12. And we're not given the units, so we'll just say that that's some sort of square units, whether it's inches or centimeters or whatever, okay? Well, let's look at the next picture. What's the area of the shaded portion of this rectangle? Same rectangle, but they just want the shaded part, okay? Now, how am I going to find just the area of the shaded part? What fraction of the entire rectangle is the shaded part? Do you see it? It looks like it's half, right? It's going to be half of the area of the rectangle. And that's true all the time. If you have a rectangle and you connect the vertices to make a diagonal and you make it into two triangles, you're going to have the area of one of those triangles be half of the area of the rectangle. So we could figure out the area of this rectangle. We could say, well, that just means I'm going to take the length and the width again, and then I'm going to divide it by 2 to cut it in half. So the area there would be equal to 12 divided by 2, which is 6 square units. It's just half of the rectangle. And we have a formula for that. The area of a triangle is equal to the base times the height divided by 2, okay? Or, like we mentioned a minute ago, that's the same as 1/2 of the base times the height. So a lot of times you'll see it written like this, or you'll see it written as base times height divided by 2. Either way, that's fine to think about them that way. Okay, now why are we not calling it length and width? Okay, well, let's look at some other examples of triangles here. Let's look at B. Now, I didn't mark any measurements off on this, but we will as we go. Okay, so for this triangle, it's not half of this rectangle like this. It's not as easy to see what you're going to do. And we've already seen that our variables, we're going to call these base and height. So I can't call this my height, this slanted part, okay? And I can't call this my height. Think about it. When you go to the doctor's office and they're going to measure your height, you don't lean over, do you? No, you're going to stand up straight. You're going to make sure, you want to make sure they get you as tall as you are, right? You may want to stand on your tippy toes. So when you're standing straight up, that's how they're going to measure your height. So the height is defined, and it says this in your book, as the distance from the base of the triangle to the opposite vertex. So let's call this bottom here the base, and that would make this kind of straight, the height. Okay, there's another name for height. It's called the altitude. Now, when we're talking about people, we talk about height. We don't say, what's your altitude, right? But if we're talking about mountains, sometimes we will talk about the altitude. So you can use them either way here. So your area for this one, you would do base times height. So let's go with that same measurement that we had in the last one, where this base is 4 and then the height is 3. Your area would be equal to the base times the height divided by 2, which is 4 times 3 divided by 2, which is equal to 6, whatever the units are squared. Okay, so you would get the same area that we got for the last triangle that we did. But the height was not over here. The height was inside of the triangle because we couldn't have a slanted height. Now, in what makes this first triangle that we did special, it's a right triangle. It was part of a rectangle, half of a rectangle, so we know that we have a 90-degree angle here. So that gives us the height. Here, we had to draw in our height, and they'll usually give that to you. Let's look at another example. Here, I can't say this slanted part is my height, and I can't say this slanted part is my height, and I can't draw a line up here to this vertex. I can't do it this way because that wouldn't be the total height. So what is the height for this triangle? Well, sometimes you have to extend the base. So let's call this the base, and let's extend the base out to where we can drop a perpendicular line from it. This will be our height. So sometimes your height is on your triangle. If you've got a right angle there, it's really nice. There's your height. Sometimes it's inside your triangle. And sometimes you're going to have to extend the base, like we did here, and make it perpendicular to that extension. Now, it's important when you look and you try to do the area, you're not including this piece as part of your base. We just extended it to be able to find the height. So let's put our measurements in again. This base is 4, and this height is going to be 3. Okay, so our area is going to be equal to 1/2, or I'm going to write the way the book does, base times height divided by 2. Area is going to be equal to 4 times 3 divided by 2. Area is going to be equal to 6 square units. Okay, and that's how we're going to be able to find our area of a triangle, is using that formula. Just keep in mind that your height or your altitude could look different, but you're not going to have a slanted height. It has to be 90 degrees, a 90-degree line to the base.